So in the lecture series of mechanical metrology, mechanical engineering metrology, now next topic is screw thread measurement. Similar to the gears, screw are also common in mechanical systems. Generally, screws are used for motion transmissions and for fastening purpose in any mechanical structure or in any mechanical mechanism. So that's why it is very much important to discuss about how to do measurement of different features in screw threads. Screw threads are again complex in nature, similar to the gears, even I would say more complex than gears. So there are so many different types of standard threads are available, but most general British standard Whitworth screws are common. That's why in this topic we'll be only discussing about methods and techniques to do measurement of thread which are of BSW type or which are of V type. So we'll be only discussing about screw thread metrology of British standard Whitworth, or this is also called as a V thread. So we'll be discussing about this. This buttress thread, British Association thread, knuckle, American standard, these threads are also there, but they are special purpose threads. They are not more general, but these threads, they are more general. So we'll be discussing only about how to do measurement of BSW type of threads. So now next is screw thread terminology. We'll try to understand basic terms related to threads, screw threads. So here you can see one drawing, and I would also like to show you another drawing. Here this top one is for external threads, and this one that is for internal threads. So this is male component actually, which is having external threads, and this is female component which is having internal thread. If you consider screw and nut, then screw are having external threads and nut is having internal thread. Both are having threads, so there is minor change in the terminology or the understanding of terminology when we are talking about external threads and internal threads. That's why these two drawings are indicated here. Later I'll show you what is the basic difference. So first we are starting with screw thread. What is the screw thread? See, screw thread is nothing but helix groove cut on external thread or inside the internal thread, on external cylinder or inside the hollow cylinder. That is called as a screw thread. So if you look here, you can see this type of profile. This profile is called as a screw thread. Similarly, if you look here, if helix is cut, this curve is called as a helix curve. If helix is cut on outside of cylinder, then that is called as an external thread. If helix is cut inside the hollow cylinder, then that is called as an internal thread. So that is what the external thread and internal thread. Screw thread can be cut on a cylinder, then that is called as a straight thread. If screw or the helix groove is cut on cone, outside of the cone, then that is called as a conical screw thread. So that is what the again difference between straight thread and conical thread. So here in both the drawings we have considered cylinder. So these two are straight threads, or it is also called as a parallel thread. Now next is axis of thread. So you can see here one line which is in the length of screw. Then this chain line is called as a here you can see one line. this vertical line, which is called as the axis of thread, which is in line with the length of screw. So that is what called as the axis of thread. Now next is right hand side thread and left hand side thread. To understand this right hand side thread and left hand side thread, if you imagine that you are rotating screw in clockwise direction, and if screw is going away from you, then that is called as a right hand thread. Opposite to that means if you are rotating screw in clockwise direction, but if screw is coming towards you, then that is called as a left hand side thread. So that is what the right hand side and left hand side thread. More general, you will find right hand side thread. In some of the applications we are using left hand side thread. Otherwise right hand side thread is more common. The next term is form of thread. If you look here, this helix curve which is cut on cylinder, that is called as a form of thread. So in previous slide, if you look, these are the different forms of thread. Clear? So that is what the meaning of form of thread. The next term is crest of thread. So if you look in this diagram, then you can see here the topmost point on this thread form. This topmost point on this thread form, that is called as a crest. Similarly, if you look in this diagram for external thread, this topmost point, that is called as a crest. Similarly, in internal thread, this topmost portion, that is called as a crest. Clear? Now, what is root then? If you look here in this form of thread, if you look this bottommost portion of thread form, that is called as a root, which is written here. This is root. So similarly, if in case of internal thread, you get this as a root. In case of external thread, you get this as a root. In case of internal thread, you get this one as a root. Yeah, so that is what the crest and root of thread. Now next is about flank of thread. See, the straight part of thread form which is connecting crest with the root, this line and this line, they are called as a flank. So that is what called as a flank. So that is written here, this is flank. This is called as a flank. The straight line which is connecting crest with the root, that is called as a flank. Now angle of thread. So you can see here, angle of thread is included angle between two flanks. Next is flank angle. Half of the thread angle, that is called as a flank angle. So half of the thread angle, that is called as a flank angle. Thread angle is one important property in thread metrology. So that we'll see later in our subsidiary discussion. Okay. Now, what is pitch? Pitch is called as the distance measured parallel to axis. The distance measured parallel to axis of thread between corresponding points on adjacent thread form in the same axial plane and on the same side of axis. So if you look here, along the length of thread, along the axis of thread, if you measure distance between two similar points, two successive points, means if you pick this crest, then crest to crest distance is called as a pitch. If you pick this root, then root to root distance is called as a pitch. If you pick this point, then same point or similar point on the next thread means this distance, that is called as a pitch. Okay? Pitch is very much important property because that defines how much linear movement thread or the screw travels per revolution. So that's why pitch is very much important property. Now next is about lead. Lead is also same, how much amount of linear distance traveled by screw per revolution. That is called as a lead. Lead and pitch would be different if it is about start of thread. Means if thread is a single start thread, then pitch and lead both are same. But if multi-start threads, means on same cylinder you have cut so many different helical grooves, then you get variation in the pitch and lead. For example, if you consider two-star thread, then two helical grooves are cut on same cylinder. Then for two-star thread, lead is equals to twice the pitch. So more start of thread, then you get more quick movement of screw per revolution. Now next term, that is thread per inch. This is actually British standard to define pitch of thread. Thread per inch means how many helix curve per inch axis length of thread. So thread per inch, which is generally abbreviated as TPI, thread per inches, then TPI is inverse of pitch actually. So pitch and thread, they are actually passing same information, but in British standard we are defining TPI. In metric standard we are defining pitch. Next is helix angle. To understand helix angle, if you open cylinder, if any cylinder, on any cylinder, if any helical groove is cut, and now if you open that cylinder, then that helical groove that follows this straight line, and perpendicular to this means the vertical line that indicates the axis of thread. Then angle between this angled line, which is actually helical groove, this straight line actually indicating helical groove, but when you rotate this straight line by one revolution, then you get a helical groove, then you get a helix. Clear? Then helical angle is indicated here. It is angle between helical line with the base of thread, or with the line perpendicular to axis of thread. That is called as a helix angle. Clear? So if you open helix curve, then you get this type of right angle triangle. Now next is about depth of thread. So what is depth of thread? That is clearly written here. Depth of thread is distance from crest to root. This distance is called as a depth of thread. Then next is axial thickness. What is axial thickness of thread? Then you can see here axial thickness is nothing but along this pitch line. Before understanding axial thickness, let us understand what is pitch line. See, pitch line is line, this line. Pitch line is line parallel to axis and located such that it divides space and thread portion equally. Then that location is called as a pitch line. So again I am repeating what is pitch line. Pitch line is a line parallel to axis and located at a position such that this space length and solid screw length both are same. That is called as a pitch line. Okay, so now again back to axial thickness. Then this solid portion, this much of solid portion of thread, that is called as a axial length. Axial thickness. This is called as a axial thickness. So axial thickness of thread and axial space of thread both are same on pitch line. Now next is about fundamental triangle. So here you can see this ABC, that is called as a fundamental triangle. So how to define fundamental triangle? If you extend this flank, then both the flanks, they intersect at point A. That point A is called as an apex, which is on crest side. So A is called as apex. Similarly, on the other side, if you extend this flank lines, then you get B and C, which are similar to the apex A on the other side. See, if I extend this flank and the flank of next thread, then I get point C. Similarly, if I extend this flank and flank of previous thread, then I get point B. Then this triangle ABC is called as a fundamental triangle. Now next is truncation. What is truncation? See, if you look here, this A, if we follow ABC, then it's a pure triangular thread. But for good operation or noise-free operation, if you look here, it is written root truncation. Means instead of the sharp corner, instead of this apex, we are curving this end, this apex. Then how much distance between apex to the crest, or distance between this apex to the root, that is what called as a truncation. So in most of the threads, this root truncation and crest truncation, they are of same value, but in special cases you can change. So here that is written, it's a crest truncation, and this value is called as a root truncation. So that is actually radial distance between apex and crest, that is called the crest truncation, and radial distance between apex, lowermost apex to the root, that is called as a root truncation. Clear? So similar to like we are providing fillet on any component to remove sharp corners. Similarly, in case of thread, we are providing truncation to avoid sharp corners, and we provide a good circular surface. So that is what called as a truncation. Now next term is addendum. Then what is addendum? So if you look here, distance, radial distance from pitch line to the crest, this is called as a addendum. And radial distance from pitch line to root, that is called as a dedendum. So addendum and dedendum. Now next is major and minor diameter. See, in case of gears, we will be having so many circles. In those circles, three are very much important. One is addendum, second is dedendum, and third one is a pitch circle. So similarly, in case of screw also, three possible circles. One, you can consider one cylinder which is tangent to the crest of all these threads. Then that is called, then diameter of that cylinder, that is called as a major diameter, or we can say addendum diameter, similar to the gears, okay, because this distance is addendum. So if you consider one cylinder which is tangent to all this crest, cylinder which is tangent to all this crest, and diameter of this cylinder, that is called as a major diameter. Similarly, now consider one another cylinder which is having surface, its lateral surface tangent to all roots of thread, then that is called as a minor diameter. And now consider one another cylinder which is tangent to pitch line, then that diameter is called as a pitch diameter. Okay, so these are the three diameters related to screw thread. And in our next discussion, we'll be only discussing about how to measure these diameters of screw thread, how to measure major diameter, minor diameter, and pitch diameter for internal as well as external threads. So that would be covered in our next session. So this is about basic terms related to screw thread metrology. Now elements to be checked. So as I told you, we'll be measuring major diameter, minor diameter, and effective diameter. See, that diameter of cylinder which is tangent to pitch line, that is called as a pitch diameter, effective diameter, mean diameter. These all are same. For screw thread metrology, effective, mean, and pitch diameter, these all are three. So we will be measuring these three diameters. We can also measure pitch, angle of thread, and form of thread, whether perfect helical form is present or not. But we'll be only considering, or we'll be only discussing about how to measure these three diameters and angle of thread in this series of lectures. Then possible errors. The first one is the drunken thread. If you look here, as I told you, if what is first of all helix? Helix curve actually. If you consider any point which is rotating about cylinder, lateral surface of cylinder, and during rotation it is also moving straight along the axis, then curve traced by that moving point is generates helix curve. Clear? Then curve traced by that moving point, that is helix. So if you open that lateral surface of cylinder, and now if you indicate path or the locus of that moving point, then you get this straight line, as we have already discussed it earlier. So you get this straight line. But drunken thread meaning is, instead of this straight line, you get this type of wavy profile. Now drunken thread means it is having error in form of thread. Instead of straight line, we are having this type of uneven thread. But you can easily see here, for perfect thread and for drunken thread, pitch value is again same. So per revolution thread will move same distance, whether it's having true thread or it's a drunken thread, but pitch would be same. Pitch distance covered by would be same. But due to this drunken thread, you will not get a good free rotation of screw in nut. Clear? So that is the issue with this type of error, drunken thread error. Now next error, that is pitch error. Now in drunken thread error, we are not having any pitch error. Pitch remains same. But what is the pitch error? So to understand this pitch error, you can see here. Here x-axis indicates length of thread and y-axis that indicates cumulative pitch error, means variation in the pitch. We have already discussed what is pitch. Pitch is amount of distance traveled by screw per revolution of thread. So if you look here, that pitch error is constant, not constant, but it's progressively following this inclined line. Then that is called as a progressive pitch error. That is called as a progressive pitch error. So if progressive pitch error, then this diagram indicates progressive pitch error. But if you look here, that pitch error is not progressive, means it is not following this inclined line, but it is following this type of curve nature. So if you look in this length, this profile is again repeated in second cycle. It is again repeated in this second cycle. So that type of pitch error is called as a periodic pitch error. Means for in the particular zone, you get some variation in the pitch, and same variation in the pitch will be repeated in the next duration. So that is what called as a periodic pitch error. So that is basic difference between progressive pitch error and periodic pitch error. In progressive pitch error, at the end of length of thread, you get a large variation. In case of periodic pitch error, that variation remains constant per cycle. But during cycle, you get variation non-linear. So that is what the issue with the periodic pitch error. Okay. So at the end, suppose after 10 revolution, you get some constant error in case of periodic pitch error. But in case of progressive pitch error, in each revolution, error is cumulative. So at the end of 10 cycle, you will be having some large value of pitch error. Okay. So I hope this session is interesting and fruitful to you. We have discussed basic terminology and need of this topic, why we need to do screw thread metrology, why we need to do screw thread measurement. So in next lecture, in next session, we'll be discussing about how to measure major diameter, minor diameter of internal and external thread.